Hello student, in previous lecture we have discussed two important theorems and some examples. The first theorem says that if your sequence xn is a monotonically increasing sequence and which is bounded above, then it is converges to its least upper bound. And what the second theorem says, if your sequence xn is a monotonically decreasing and bounded below, then it converges to its greatest lower bound. Okay, now today we are going to see some examples. First example, show that the sequence AXN is equal to 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus dot 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 1 upon n factorial converges. It's convergent sequence. Show that this sequence Xn is a convergent sequence. So we are first thing is what we are going to check whether this sequence is monotonically increasing sequence or monotonically decreasing sequence. For that, consider the difference of finding the xn plus 1. What is the xn plus 1? 1 upon 1 plus 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus dot 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 1 upon n factorial plus 1 upon n plus 1 factorial. So if we take the difference of xn plus 1 minus xn, then what happen here? If we take the difference of these two terms, then 1 minus 1 will get cancelled here. 1 upon 1 factorial, 1 upon 1 factorial will get cancelled here. This term will get cancelled here. All these terms will get cancelled. Only 1 upon n plus 1 factorial is termless, but it is a greater than 0. It is a greater than 0. So what this implies, xn plus 1 minus xn is greater than 0, and therefore xn plus 1 is greater than xn, and therefore this implies xn is monotonically increasing sequence. Is it what? This sequence is what? Monotonically increasing sequence. Now if you want to show that this sequence is a convergent, we have to show that this sequence has an upper bound. This sequence has an upper bound. Okay, now I am writing this sequence again. With xn xn is what? 1 upon 1 factorial, 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon 4 factorial plus dot 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 1 upon n factorial. In the first step, we have shown that we have proved that this sequence is a monotonically increasing, and if we want to show that this sequence is a convergent, we have to show that this sequence has an upper bound. So all of you know that what is 1 upon 3 factorial is what? 1 upon 3 into 2, but this is less than 1 upon 2 into 2. Why? Because this 2 as it is, but since 3 is greater than 2, this implies 1 upon 3 is less than 1 upon 2, and therefore this 2 as it is, but this 1 upon 3 is less than 1 upon 2, but it is equal to what? 1 upon 2 raised to 2. Similarly, 1 upon 4 factorial is equal to 1 upon 4 into 3 into 2, but which is less than this 2 as it is, but this 3 is less than 2, that is 1 upon 3 is less than 1 upon 2, 1 upon 4 is less than 1 upon 2, so this is what? 1 upon 2 cube. Similarly, if you proceed further as n, then 1 upon n factorial is less than 1 upon 2 raised to n minus 1, is less than 1 upon 2 raised to n minus 1. So all this xn is less than 1 as it is, 1 upon 1 factorial as it is, that is 1 upon 1 factorial as it is, 1 upon 2 factorial again, 1 upon 2 factorial is what? 1 upon 2, 1 upon 2 factorial is 1 upon 2, but this 1 upon 3 factorial is less than 1 upon 2 raised to 2 plus 1 upon 2 raised to 3 plus dot 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 1 upon 2 raised to n minus 1, 1 upon 2 raised to n minus 1. We can write this as 1 plus, if you write this term inside the bracket, that is 1 plus 1 upon 2 plus 1 upon 2 raised to 2 plus dot dot 1 upon 2 raised to n minus 1. All of you know that this is a geometric series. This is a geometric series having first term. First term is 1 and common ratio is 1 upon r, and all of you know that as n tends to infinity, our geometric series Gn is converges to a upon 1 minus r. R is a common ratio, a is the first term. So this is a geometric series. This series is converges to, and r is lie between 0 and 1. R is what? R is 1 by 2, which lie between 0 and 1. So it converges to 1 plus first term is 1. That is a 1 minus r, so 1 minus 1 by 2, so it is equal to, if you simplify this, 2 minus 1 is 1, and if you take this 2 on the numerator, it is 1 plus 2 is what? 3. 1 plus 2 is what? This statement is equal to this, but xn is less than what? 3. So xn is less than 3. Means what? Each term of the, for every n, it means what? For every n, xn is less than 3 means what? Our sequence is, sequence has upper bound, but if the sequence has an upper bound, what this implies? Sequence xn is bounded above, but the given sequence is monotonically increasing and bounded above, therefore sequence xn is what? Convergent sequence. Sequence xn is what? Convergent sequence. Okay,